Hello everyone, I am Dr. Buddhika Liyanike. So I would like to talk about this empirical formula question today. A 10-gram sample of compound containing only carbon, hydrogen and oxygen. So after combustion, 23.98 grams of carbon dioxide and 4.91 grams of water, H2O, produced. What is the empirical formula of this compound? So let's go and find out step by step. Carbon dioxide. Carbon dioxide is converted into number of moles. Divide by carbon dioxide molar mass 44 grams per mole. Then we can get 0.545 moles of carbon dioxide produced. So you can clearly see 1 mole of carbon dioxide contain 1 mole of carbon atoms. So then moles of carbon is equal the same value 0.545. Then what is the carbon mass? Number of moles multiplied by the atomic mass of the carbon 12 grams per mole, then we can get 6.54 grams. So there are 6.54 grams of carbon occupied inside this 10 grams. Let's do the same treatment for H2O. H2O 4.91 grams divide by the molar mass of H2O 18 grams per mole, then number of moles 0.273. This is number of moles of water H2O. But inside this formula you can see 1 mole of H2O containing 2 moles of hydrogens. The number of moles of hydrogen should be double this amount. 0.273 multiplied by 2. It is 0.546 moles of hydrogen. So let's convert these moles of hydrogen next into grams. So hydrogen mass, molar mass, atomic mass is 1 grams per mole. Then the gram amount is the same value 0.546 grams. So this is the amount occupied inside this 10 grams. Now, if you know carbon mass and hydrogen mass, how we can calculate the oxygen mass? Carbon mass plus hydrogen mass plus oxygen mass is equal 10 grams. So if we subtract the carbon and hydrogen mass from the total mass, we can get the oxygen mass, that is 2.914 grams. Now let's convert this oxygen mass into moles of oxygen. Divide by the oxygen atomic mass 16 grams per mole. So if we divide the mass by molar mass, it is result number of moles 0.182. Now we have number of moles of carbon, number of moles of hydrogen and number of moles of oxygen. Let's tabulate the results. So we can't get the whole number ratio just by looking at these three decimal values. Then to get the whole number ratio, we divide these three numbers by the smallest number appeared here. So among these three, the smallest number is 0.182. So if you divide each value by 0.182, we can reach 3 carbons, 3 hydrogens and 1 oxygen, the whole number ratio. Then our empirical formula is C3H3O. This is not the actual formula of the compound. To calculate the actual formula, we need one more step forward. We need the molecular weight and then we can find the actual formula. This is empirical formula of this compound. I hope now you understand the question. Thank you all for watching.